Good morning, all of you. Today I'm going to solve thermal energetic based questions. In chemistry thermodynamics, there are two parts, thermal energetics and thermodynamics part. And the last two videos that I have posted containing thermodynamics based question. This is actually a thermal energetics based question. This is actually a JEE question. Let us solve this question. Ethanol can undergo decomposition to form two sets of product. So two sets of product it is giving, but it is not in the equal ratio. It is not actually a 1:1 ratio. It is 8:1 ratio. So we should not write 2 moles of ethanol giving 1 mole of ethene and 1 mole of acetaldehyde. Because if we are getting the equal amount of ethene and acetaldehyde, not necessary to worry about anything. Just we can take 2 moles of ethanol and we can convert that for 1 mole. But here the product percentage is differing 8:1 ratio. It is in actually 8:1 ratio. So we have to write one more equation, and from that we can get the data. So what they are asking, actually the energy involved in the decomposition of 1 mole of ethanol. So 1 mole of ethanol means you can directly take like that, 2 moles of ethanol giving 1 mole of ethene and 1 mole of acetaldehyde, and 1 mole of ethanol will give how much, like that you can calculate. But if they have given 1:1 means you can calculate like that, but here it is not like that. That is why we should use another one technique to find out that 1 mole of ethanol decomposition energy involved. So shall we shall take this. If you are taking 9 moles of, why I'm taking 9 moles, 8 plus 1, right? Look at this, 8 plus 1, so 9 moles of ethanol. Ethanol, what is that? Ethanol, ch2, sorry, ch3 ch2oh, primary alcohol, right? So you will get 8 moles of ethene, C2H4, and then 1 mole of acetaldehyde, right? This is the actual reaction, and 8 moles of H2O and 1 mole of H2. This is actually this is the actual reaction. So 9 mole is giving 8 mole, but they are asking the decomposition reaction for 1 mole of ethanol. That's why I'm going to choose. If you are taking 9 mole of ethanol, that is 9 mole of CH3 CH2OH giving only 8 mole of C2H4, then 1 mole of ethanol will give how much C2H4? 8 into 1 by 9, that is 8 by 9 mole of ethene. So it is giving 8 by 9 mole of ethene. So look at this. If you are getting 1 mole of ethene, the energy involved will be 45.4. But if you are having 8 by 9 moles means you have to select, that is you have to multiply that energy involved by 8 by 9. So shall we do that? So 1 mole of C2H4 involved 45.54 kilojoule. Then 8 by 9 mole of C2H4 involved 45.54 into 8 by 9. Actually, it will be 40.48. I will use the calculator, but please don't use the calculator. 45.54 into 8 by 9, right? So you will get 40.48. So for C2H4 conversion, I found. Now I am going to write another one equation. Kilojoule, unit is kilojoule. Another one equation, that is 1 mole of same ethanol. 9 mole of ethanol is giving, that is CH3 CH2OH is giving 1 mole of CH3 CHO. Then 1 mole of ethanol will give 1 into 1 by 9. So look at this, the process involved for 1 mole of ethanol from, that is 1 mole of acetaldehyde from ethanol will be 68.91, but we are getting only 1 by 9 mole, right? So 1 mole of acetaldehyde from the decomposition of C2H5OH will be 68.91. but we are getting only 1 by 9 mole of ethanol, that is acetaldehyde. Ethanol, I am saying ethanol, 68.91 into 1 by 9. So how much we will get? 68.91 divided by 9, right? So 7.656. This is actually for ethanol. That is ethanol. It's not ethanol, ethanol. And this energy is for C2H4 decomposition. So for all that, I have taken only 1 mole of ethanol, right? For 1 mole of ethanol, we are getting 8 by 9, and 1 mole of ethanol, we are getting 1 by 9 ethene and acetaldehyde respectively. So for that, I have calculated that energy. If you are adding the total energy, you will get 40.48. You will get 48.137. That is, you will get the answer by adding delta H total will be 40.48 plus 7.656. Totally, you will get 48.137. Actually, it will be 1366 kilojoule. So let us check whether our answer is right. Yeah. So look at this. If you are having only 50-50% means not necessary to bother about that things. You can just take the 2 moles of ethanol and you can convert that for 1 mole. But here we are not getting 50-50% product. 8 is to 1 molar ratio we are getting. That is why I have chosen the 9 moles of ethanol is giving 8 moles of ethene and 1 moles of acetaldehyde, like that. Hope you understand. Okay, let us solve the second question. This is actually also a JE based question, somewhat tricky question. Look at this. The question was very nice. Uh, the formation of water is 285.8 kilojoule per mole. So I'm going to write the given data. Given data means formation. Formation process in the thermal energetics will be always from the elemental state. So formation of water means H2O. We have to form H2O. Hydrogen is the elemental state. H2 is the elemental state of hydrogen atom, and 1 by 2 O2. If you are taking the elemental state of oxygen, then there should be 1 by 2 O2 to get the 1 mole of water molecule. This is actually a balanced equation of formation of water from the elemental state of hydrogen and oxygen. Always the formation should be 1 mole, and that should be in the elemental states. Please don't forget that one. And then the second one, what the enthalpy of neutralization of monoacid strong base is. So for mono acid strong base means, what is that? The neutralization enthalpy. That's all. H plus and OH minus gives H2O. This is actually neutralization enthalpy. Look at this. Both will form a 1 mole of H2O, but we are not taking that second one as a formation enthalpy, because the formation enthalpy definition will be the 1 mole of the product will be formed from the elemental state of constituent atoms. So be please careful on that point. So here delta H of neutralization will be, what is that? Minus 57.3. And here it will be formation of water. Actually, this is a, you can take that as a decomposition reaction of hydrogen also. It's not decomposition, combustion. So 285.8 kilojoule per mole, and here it will be 57.3 kilojoule per mole. I didn't write the unit. Okay, and then they are asking the formation of OH minus ion. OH minus ion means the constituent atoms are O and H. That's why I'm going to take half O2 and half H2, because for oxygen we should not take considerably only one oxygen atom. It's not possible to take that in elemental state. So oxygen will be in O2, always in the elemental state, right? In the elemental state, oxygen will be always in O2, diatomic molecule. And then one electron we should add. This is the actual formation of hydroxide ion. So we have to get that. That's all. We have to get that equation, and we have to find the delta H for that formation. Okay, let us check how we can do that. Here, look at this. We are getting OH minus on the right hand side. So I'm going to write the neutralization equation by taking like this. H2O gives H plus and OH minus. So I have just reversed that equation. That is why I'm going to write the formation in the reverse enthalpy for that reaction will be 57.3. Just I have reversed the sign. That's all. I have changed the sign because I have reversed that equation, right? Okay, and then the second thing, OH minus, I have got, but here H plus is there. I don't know how to remove that H plus, but if you are taking hydrogen, that is H plus in the right left hand side, then only it will be cancelled out. H plus should be cancelled out, right? So H plus is only in the neutralization equation. So I need another one equation that should contain H plus in the left hand side. How I can get that? Half hydrogen giving H plus and removal of one electron, the delta H for that reaction will be 0. This is a fixed case. Delta H of the reaction will be 0 for that case. So I am going to take that equation and I am going to reverse that one. H plus and one electron gives half H2. So the second equation also I have selected. So the H plus problem solved, and the electron has also added at the left hand side, right? And then I have to remove H2O in the left hand side, right? For that, I am going to take that first equation. H2 plus half O2 gives H2O. It's not half H2O, H2O. If I am adding all that equation, so here it will be 0. I have taken that reaction as such to 85.8. If I am adding all that equation, what will happen? Left hand side and right hand side, I am going to add all the equation. I will cancel if the element is present in the left hand side as well as right hand side. So I am going to cancel that one. H plus is present in the left hand side and H plus is present in the right hand side. That's why I have cancelled that one. And half H2. Here one H2 is there, here half H2 is there. So I have cancelled that one. So half H2 will be cancelled and half H2 will be remaining. And then half O2 is already there, H2O, H2O cancelled. That's all. So I'm adding that equation. After that adding that equation, I am getting the exact equation what I need. Half H2 is remaining, half O2 is remaining, and the electron is remaining, and the OH minus on the right hand side will be remaining. So after adding that, I'm getting our needed equation, right? That is why I'm going to add all the enthalpy. 57.3 plus 0 minus 285.8. So what's the answer? 285.5 means approximately it will be nearly 228, right? So 228 minus 228.5 kilojoule is the answer. So somewhat tricky question, right? Here the important point you should know, if you are getting the ion from the elemental state of hydrogen, will be the energy involved in that process will be 0. That is the main point. Thank you.